Hey guys, Kyle here with the Brothers Claws. Just thought I would inject a little before we start this video. I actually recorded this a week or two ago and decided not to upload it because I thought it got a little lengthy. So what I'm going to do today is I'm actually just going to upload the beginning part where we go over the wiring because Tagh and Direwolf did a great job of showing off their clock, but this one's a little bit different and I think the wiring is easier to see and understand. So you'll hear me say in the video that I'm going to go over the code, but I'm actually going to save that for later if people are interested. If you are interested in seeing the code itself, go ahead and hit a like on this video, and if we hit enough likes, we'll upload the video with the code itself. We may re-record it because it gets a little slow and dry. So anyway, if you like the video and you want to see the code behind it, go ahead and hit a like. If not, if you're just interested in seeing the wiring and some of the detail of how it works on the outside, stick around and take a look. Hey everybody, it's Kyle here with the Brothers Claws. I just wanted to do a follow-up video with the wrench clock. A lot of people will checked out the video. I appreciate it. What we've done is made a couple other little tweaks, actually tweaks that were requested for the wrenched map. So without further ado, let me demo some of this stuff. This is going to be a little more behind the scenes than the last one, just because there's not a whole lot more added. So if you are not interested too much in the code, this might be a little boring to you. So a couple of changes to the layout. I cleaned it up a little bit. It's a little more compact, and then you'll notice there's three wireless things up here. Now in the wrenched map, they ended up hardwiring everything, so that's why there's that new platform up there. If you look, there's actually some jacketed bundled cable coming across because there's a potential here for other players interfering with the clock operation if you have it on wireless. So ours is on wireless with I've got remotes in my hands for start, stop, and reset. The official clock ended up being hardwired just to prevent that. So let me just get started here. I've rebooted this machine and we're just sitting at a blank command prompt. There's no words in here right now other than the default ones. What we've got is on the disk, the very first section, and I've refactored all the code, so now it's all in sections. The very first section is actually the install function. So if you do a one load, what it'll do is it'll create the installer. So this will take a little bit of time, so I'm actually going to clip the video and I'll come back as soon as it's ready to go. Alright, so that's loaded. Before I run this thing, let me clear up the page real quick and just show you what this thing does. So all that this installer does is it basically just loads each of the sections there. So you can see starting at line 4 is where it actually starts doing stuff there, where it's going to load the variables, and it just loads block 2, then block 3, and block 4, etc., all the way down. And so those are each of the sections. So I'm going to go ahead and run the install, and what that's going to do is just run through each one of those sections and essentially run our things. And the purpose of this entire block is just to simplify reloading everything, because you have to do them in a certain order because of certain functions or certain words rely on other words. So this was put in so that as we're working with code, we can just reset the whole machine and start over real fast and just do an install and we're done. It also makes it much easier to share the code. So that's that. So again, this is going to take a little bit of time. This particular step takes a very long time because it's a lot of ifs, and the compiler is pretty slow about compiling ifs. So I'm going to clip the video again and come back to you once we're done installing the new clock software. Alright, the install is done. So I'm going to go over what each of these things are a little later. I want to first show you how this works. So essentially the computer just sticks in an infinite loop. That's what the start command does, and it starts the clock program. It doesn't actually start the clock running, but starts the clock program. So you'll notice that nothing's actually happening even though the computer is running through its cycles. So let me go over what some of this stuff does. So the wireless signals down here, we have think left to right, start, stop, and reset. I could have my orders wrong. Um, and they're hooked up to these latches. Now, the latch idea was definitely not mine. That was Tagh's. We had a slightly more complicated setup earlier, but this works out really well. So the computer is essentially waiting for a low signal on each one of these inputs, and as soon as it picks it up, it will reset the latch. So let me start with a reset just because it won't do anything to the clock, which I believe is this one. So you'll see what happens when I pulse this thing. The latch is going to switch and it's going to pull the current over on the other side. And then the computer will pick that up and it'll reset this back on. So from here, all we'll basically see is the redstone signal get turned off on this redstone wire and then flip back. So it's flipped and it didn't flip back. Why didn't it flip back? Oh, I apparently have a bug in the code. I'll be right back. Alright, sorry about that, guys. I got that fixed. It was a little bug that I had fixed earlier, but I had forgotten to flush it to the disk before I reset everything to start this demo, so it didn't get loaded. So anyway, back to what we were trying to show you. If I hit the reset, we will pull the redstone signal to the right-hand side, and then eventually, once the computer picks it up, which it should do within 5 ticks or so, I think at most half a second, it will pull it back. So that's what's going on. Same thing with the stop and the start, although at the moment, since the clock's not running, the start won't ever get pulled back. Well, it might. Yeah, it does get pulled back. Start is really the one that's interesting. So as soon as we tick the start, you'll see that the clock starts going. You'll notice that this hasn't been pulled back yet. The computer has detected the start condition but has not finished the loop. So not until I tell it to stop or it actually runs out of time does it do anything. So let me throw a stop in here and you'll see both get reset. So let's do that one more time from the front so you can see what's going on. I'll throw a reset at it, and that resets the clock back to 30 minutes. We hit a start, the clock will start ticking. And then the last thing we have is a stop, which lets us stop the clock or pause the clock essentially, because we can hit a start one more time and it will continue going right from where it was at. The reset does not do anything while the clock is running, which is sort of a mistake, but it turned out kind of well in the end, because you don't want to accidentally hit reset while the clock is running. So we'll stop it and resets everything. So those are a couple of things that were added. The one other thing that was added requires a little bit of hokey pokey on my part. So let me hop in here real quick and trick the machine. We will set it for, let's set it for 2 minutes. So I have manually set it for 2 minutes. The reset automatically does 30 minutes. That's why I'm doing this. And then we'll start it back up. So I've kind of just injected a little bit of code into the thing there, told it to start at 2 minutes. So if I start this clock, we'll start at that 1 minute mark and it'll start counting down, and you'll see that it actually counts the seconds now. The final 60 seconds get counted on the LCD display as well, so that it's very clear how much time is left when you get to the last little bit. So I should have set this for 1 minute. I'll be right back. Okay, final few seconds of this 1 minute. So it's 1 minute, 3, 2, 1. Now we're down and we're going to count the seconds on the LCD. So that's pretty cool. And getting that implemented took a little bit of work. Not a lot, actually. A lot of the code was already in there, and I think you'll see when I go over the code how it's structured that it wasn't terrible, but it did take quite a few iterations to get it to work perfect, to work simply, I should say, not perfect. So anyway, it just is going to count down all the way to 0, 0, and when it gets to the final part, what we get is no ring around the edge and just dashes. That's how you know it's not just like 0 and some seconds or something like that. It's actually done. There is no more time on the clock. So we'll just stick here for just a second and I'll show you guys that. 13, 12, 11, 10. I feel like I'm at New Year's. I even have one other thing here. I don't remember if it's turned on at the moment. When I reset the code, I might not have flushed the change. Yep, there it is. So there's also a buzzer, which I don't think got turned on the actual official clock. So you'll see there's a buzzer right here. It's from, I think it's from Nuclear Control, which may be why it's not on the official wrench map, because I don't think they have that. So anyway, the clock is stopped now. I can go through and I can hit a reset to pull it back up to 30 minutes and another start. And so essentially, once you've got this thing loaded and running and you've hit start, you never have to touch the computer again. So anyway, those are the changes to the clock. What I'm going to go over now is the some of the code. So those of you who are interested in kind of how it works, this will hopefully shed some light on it. So what we've got, starting with the LCDs, which is what I'm calling them, even though that's not really what they look like, little 7-segment displays. So that's what I've been calling them. You'll see that each one of them is wired identically as far as the colors go. They're numbered similarly to the way you would number a 7-segment display if you were actually working with one, where they start at the top with number 1, and then you go clockwise all the way around, and then the 7th segment is in the center. So each one of them is wired the same way, and they each have their own I/O expander. So there's one right here and one right here. Let me grab a screwdriver. So you'll see this one should be on bus ID 3, which is just the default because that's the first one we did, and this one's on bus ID 4. So that's how that part's wired up. The rest of these I/O expanders go to the seconds display. There's 4 segments basically of the seconds displays because you can only have 16 items on a bus, and I need 60 of them. So there's every 15 seconds is on its own bus, and they're actually each wired the same way. So again, going in order, starting from the top, we have this is binary value of 1, 2, 4, etc., 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 all the way around until we get to the next 15-second segment, and so that's how they're all wired together. And then we've just got, this is bundled cable, jacketed bundled cable, just so it looks fancy, and one more up to the top. So that's how those are all coming, and those are actually set up on ID 10, 11, 12, and 13. And I don't know if I can just pick the right one. I think this is 10. Yeah. One of these, this must be 13. So this one is, this one is 11, etc., etc., etc. I think this one's the other one, 12. This I/O expander actually runs up, it's sort of for decoration. This is more bundled, jacketed. I keep saying that. It's jacketed bundled cable. Hard to think about. That just comes up to these, and it's just that way, so it's clean. We wanted to keep it all compact behind the clock so that you can't see it, see any of the inner workings from back there. Anyway, so that's the basic, really fast version of how the wiring works. Again, guys, thanks for watching. I'm going to cut the video off right there. If you're interested in seeing the code and how it works, again, hit like on the video. This is Kyle with the Brothers Claws signing off, and thanks for watching.